Good afternoon, everybody. I'm excited to introduce to you our guest speaker to today's seminar, and I will quickly read a little bit of our profile so that you get to know what our speaker is. Her name is Dr. Daroub, and she's a professor and distance education coordinator within the Department of Soil, Water, and Ecosystem Sciences at the University of Florida. He serves as the director of the Everglades Research and Education Center. Dr. Daroub earned a PhD in soil chemistry from Michigan State University and has since established an internationally recognized research and extension program. Our work focuses on the development and implementation of best management practices to improve water quality, serving as a cornerstone of the comprehensive effort to restore the Florida Everglades. A distinguished leader in our field, she is the past immediate president of the Soil Science Society of America. If you are in water or soil research domain, read it up. Dr. Daroub is there for you. Please join me in welcoming Dr. Daroub.
Thank you so much for this lovely introduction, and thank you all for being here. It's really a pleasure and an honor for me to be here. It was my first time at FIU. I don't know how I missed this university before, but I'm happy to be here. So what I would like to do today is give you a little bit about myself, my journey coming to University of Florida, and talk about the Everglades Agricultural Area, which is just south of Lake Okeechobee. I'm sure some of you are very familiar with it. Talk about the best management practices and a little bit about the Soil Science Society of America. I'm serving as past president this year, so if you're not members, I'm gonna try to. So I come from Lebanon. I got my bachelor's and master's from the American University of Beirut in agriculture and agriculture engineering. My master's was in soils. My first class at the undergraduate level, one of my first classes was in soils, and I just fell in love with that, and I continued my degrees. I came to Michigan State University to do my PhD. I got it in soil chemistry from the Crawford Soil Sciences Department at the time, and it was a wonderful experience. Eventually led me to UF. But before that, I did a postdoctoral assignment fellowship at MSU. Actually, I did two. The first one was teaching, which got me a lot of teaching experience, and I think that what got me to my position at UF. And the second postdoc was being a modeler with the DSAT crop modelers. I didn't know anything about modeling or computers for that matter, but it allowed me to really invest in another area and visit a lot of international centers, including Kenya, IFAS, and Uganda at the time from Syria. So I joined University of Florida in 2000 as an assistant professor in the Soil and Water Sciences Department at the time. Now it's called Soil, Water, and Ecosystem Sciences Department. I was always off campus. I am at a station called the Everglades Research and Education Center, close to Everglades. I had a big teaching appointment, which is unusual being off campus, but I always thought for the off-campus programs, University of Florida has a lot of degrees off campus. At the time, it was video conferencing, undergraduate programs for the most part, but now, of course, our footprint is online and it both undergraduate and graduate degrees. So I'm the distance education coordinator in the department. We have a master's science, completely online, and environmental sciences. And that degree alone, the master's program, we have about 90 students completed online. So I advise a lot of the students when they come into that program. But at the Everglades Research and Education Center about 4 years back, I got to be center director. Okay, maybe they should do that other door.
Yeah, I know. Yeah. It's
that's okay. Okay, that's fine.
garbage cans.
So just a little bit overview of the soil, water, and ecosystem sciences department. Of course, our programs are varied, but quite a bit about it is about water quality, wetlands, hydrology, biogeochemistry. Now we have a lot of ecosystem research. Soil health is a big one. Agroecology also worked quite a bit with agronomy and also modeling. So watershed modeling, GIS, AI systems now, machine learning is a big in our department. But I have the privilege of being at a center. And so the Everglades Research and Education Center is much more interdisciplinary because we have a lot of different departments. So this is what our center looked like. And if you're ever in Daroub, it's only an hour and a half north of here on US 27. It's a very diverse cropping system in the area, and that's what we cater for. So the Everglades Research and Education Center was started in 1921 because of agriculture in the area. So the center has faculty from different departments: agronomy, pathology, entomology, agriculture engineering, and soil and water sciences. We used to have wildlife ecology, but we don't anymore. But so the research that we do over there is definitely different disciplines. So we have sugarcane breeding, lettuce breeding, field corn, actually sweet corn breeding also. It's done in Gainesville, but it's done at the center. And then we have faculty that work on just soil fertility for sugarcane, for lettuce. We have rice variety testing, a lot on soil health research and urban, of course, as well as entomology, science, and pathology. I do the water quality and risk management practices. That's what I'm going to talk about today. And I just hired an ag water management specialist that will be doing a lot of irrigation, drainage type of research. Okay. So moving on to talk about the Everglades Agricultural Area, it is just here south of Lake Okeechobee, south and downstream of Lake Okeechobee. It's a very highly productive land. Somebody was telling me today that they visited and they were surprised about how dark the soils are. Of course, they are organic soils. This area was part of the bigger Everglades before it was drained for agriculture in the 1900s by the U.S. Army Corps of Engineers. So very dark soils, very productive soils, and it has a very diverse cropping systems. So I talked about sugarcane a little bit, but we have a lot of vegetables. If you go to Publix and get any type of spring mix, romaine lettuce is all grown in that area in the winter. Sweet corn is big. I mean, sweet corn you find in the market is coming from that area right now. Sod and rice. So we have flooded rice production in the summer, which is really very good for our soils because we flood our soils once they're not in production, and having rice is very good to that rotation. So because it's organic soils, the phosphorus cycle is a little bit complicated. Of course, you have the organic phosphorus, and there's a lot of organic phosphorus, but there is a lot of phosphorus in soil solution also, quite a bit in soil solution. Because these organic soils, although they may have some minerals in them, depending on the mineral content, they don't have a lot of absorption capacity. So they may have some calcium, but really the absorption capacity from research we've done in the past is related to iron and aluminum oxides. So the secondary minerals. So, and these minerals tend to increase with shallow soils. So because the organic soils, they were part of a wetland in the past, when they were drained in agriculture, something called subsidence, but it's really the oxidation of organic matter starting to happen. So we lose quite a bit of organic matter carbon, although a lot of the PMP is the best management practices that I'm going to talk to you about today has helped reducing subsidence and improving the sustainability of these soils. But when you have a little bit more subsidence, the mineral matter increases in these soils. So because it is organic soils and we get a lot of rain in South Florida, of course, these soils need to be drained. And there is artificial drainage, system of drainage, the pumps that you see here, the main canals. So these are main canals with the South Florida Water Management District. You see the West Palm Beach Canal. This is the Miami Canal, all designed to move water from Lake Okeechobee somewhere else, from the farms to somewhere usually closely south. So all farms in the Everglades Agricultural Area have to be drained when it's raining. Sometimes we use the water for irrigation. We've had a very dry winter, so definitely a lot of irrigation happening. And the water moves from the farmers' canals to the main canals by the use of pumps. So in the 1990s, actually, or the 1980s, there was quite a bit of concerns about phosphorus leaving the Everglades Agricultural Area and the impact on the Everglades ecosystem. We're very close to the Everglades, so I'm sure you've heard about it. After a lawsuit by a lawsuit that happened in the 1988, I think the federal government and I want to say the Indian tribes sued the state of Florida that they're not meeting their Clean Water Act, the Clean Water Standards Act. So after much litigation, there was Everglades Forever Act was enacted in '94. And that consent decree had also what we call an Everglades Regulatory Program. Chapter 40E63 that concerns the Everglades Agricultural Area. So goal of the regulatory program of 1994 is to reduce phosphorus loads. And I want to make sure we're all on the same page because I'm going to talk a lot about loads. Loads is a combination of phosphorus concentration in the water times the amount of flow that is coming, the drainage volume basically. So that program is concerned about phosphorus load, not per se concentrations, and to reduce it out of the EA by 25% compared to a base period before BMPs. And the Water Management District, of course, the South Florida Water Management District is in charge of that program. And they have a base period of 10 years that they compare success of the BMPs to that. But interestingly enough, this was before my time, BMP research, because they knew this was coming because of the lawsuits and negotiations with the growers. BMP research started in 1992 between the growers, the Water Management District, and the University of Florida IFAS. The BMP program started in 1995 and 100% growers participation. So this is a mandatory program. If you need to farm with EA, you have to have a BMP permit and you have to abide by all these best management practices. So there's a lot to this program, but I just summarized it in a couple of slides that if you want to discharge to the main canals of the Water Management District, so if you want to farm basically in EA, you have to have a comprehensive BMP best management practice plan. You have to have a discharge monitoring plan. So remember I told you there's canals and pumps. At each pump, of course, when they pump, they have to have samplers to figure out how much phosphorus is coming out of the ponds. And they calibrate the pumps to know how much water is. So we know exactly how much phosphorus in terms of concentrations and loads are coming from each discharge structure in the EA. And of course, part of it is that Water Management District does site verifications to make sure BMPs are implemented and to make sure we have all things done for the perfect. Part of the rule also, and of course this was done in combination and in consultation, I would say negotiations with the growers. So there is an entity in the EAA called Environmental Protection District. So part of Everglades, part of the school, so that they coordinate the research as well as the extension for all the growers in the EAA. So instead of each farmer doing their own research, because that's part of the rule, we have one board, which is the Everglades Protection District, that kind of coordinates and funds the research. So the on-farm research is conducted by mostly us, the University of Florida IFAS. It is funded by a tax on EA growers. So there are two taxes that the growers pay. There's $24.89 for Everglades restoration that goes to the state, the Water Management District, and then they tax themselves $5 an acre every single year, and that money collected by the EPA goes to research, extension, and other consultants. And of course, the Water Management District does a lot of the performance monitoring. So they figure out how much water and phosphorus coming from the lake, how much is coming out, and has the basin fulfilled its 25% phosphorus production every single year. So in addition to the growers monitoring the discharge from their farms, the district monitors what comes in and what comes out, about 2 months. And all the data from the farmers goes to the district. So just to recap, all farmers have to have a BMP permit to be able to farm. And the program uses phosphorus BMPs to reduce phosphorus concentration, but also reduce the amount of drainage, so increase water detention to reduce the phosphorus load. Every discharge structure for the growers has to have a monitoring equipment, and mostly it's auto samplers. And as far as I know, there might be other places, but as far as I know, it's the only place in the world where non-point source pollution is treated as point source, because we know exactly how much phosphorus is coming from each farm. And as mentioned, the goal of the program is to reduce phosphorus loads, not concentration, by 25%. So the program started in 1992, and there was a lot of things that made work or may not work. They started implementing it totally in 1995. And they divided these BMPs into 3 different categories. The first one is nutrient control BMPs, which really focuses on dissolved phosphorus. Things like reduced fertilizer application, banned application of fertilizers. Do not put it in a different place where it should be. So the 4 R's of nutrient management is for the soil test. Every farmer that I know in the EA has nutrient control BMPs because they're easy to follow. Also, you have to have a soil test before you apply your fertilizer. And most of the growers in the area use our soil testing lab at the University of IFAS in Daroub at the RNC. And you'll see here the band application. Then the other ones, the water management BMPs really targets both soluble, dissolved phosphorus as well as particulate phosphorus, because there might be some soil erosion with water management. But things like booster loam soil don't have to discharge water, water table management. Sugarcane is a very high quality, very friendly environmental crop because you can keep the water tables high and try not to pump as much as you can, like have more water retained on the farm. So sediment control BMPs are really big ones. And so for the water management BMPs, most of the farmers in their BMP permit, they cannot pump, they have an inch or half an inch of clay in a 24-hour period. Most of the farmers now use the half inch. So if the drain is less than half an inch, they cannot pump. The sediment control BMPs are a big list of things, and I'll talk a little bit about one of them. But really, they're designed to reduce phosphorus moved by soils and sediments, which can be quite a bit extensive and can be quite a bit of a load in the water. So it is a system of points that uses to rate the BMPs farmers can choose. Again, you have the nutrient control BMPs up there, the water management, and the sediments. And each one will have a point. They have to have 25 points, and they have to have BMPs from each of these categories. And that goes into the BMP permit, that goes into the district, it's not for the water management district, as well as the monitoring data. So I'll talk a little bit more about the particular phosphorus BMPs just a minute. So as I mentioned, the research started in 1992. There has been a lot of research projects. The research and extension in this program has been continuous since then, which is kind of amazing. But I think that is one of the reasons that led to the success of the program, because it is funded. We have projects that were funded by Department of Environmental Protection, the Water Management District, but most of it is funded by the farmers themselves, but we do research and extension. So a number of projects, I'm just going to talk about 3. And not in too much details, but as much as possible, just to give you the breadth and the width of this program and how much investment not only us at the university have done, but the growers themselves, of course, because they have to implement these BMPs, and of course the water management district. So earlier on, we looked at what is in the water. So phosphorus in the water, for compliance, we look at total phosphorus. Total phosphorus with some water. But really there's much more to it. So when we do our research, we look at total phosphorus, of course, but then we measure total dissolved phosphorus. We look at soluble reactive P, and then we calculate particulate phosphorus and dissolved organic. And they all have their importance, but I'm going to focus quite a bit on particulate phosphorus today. Again, this is the phosphorus that is with soils and sediments. And the reason being, a lot of the times the roads that we see, you have spikes and there's quite a bit of particulate phosphorus in this water sample. So this is from one example, where you see quite a bit of the spikes and they're all phosphorus in the form of soils and sediments. So this is again a very good example of what's in the water sample. Don't really get it. Quite a bit of it, of course, is water, but you can see a lot of sediments and soils in it, depending on the conditions of the discharge at that point. And this is the extreme. I'm going to give you extreme pictures. Okay. So one of the first projects I want to talk about is how much particulate phosphorus contributes to phosphorus loads in the Everglades Agricultural Area. We used to see, we're much better now, a lot in terms of aquatic plant, floating aquatic plants quite a bit in the canals. I used to see Florida have a lot of nutrients in the canals anywhere in the system, and it's hot and humid, so you see a lot of flourishing of these plants. We also, depending on the velocity of discharge, you may see a lot of transport of these, not only of the floating aquatic vegetation with the detritus, but also the sediments and the soil that might be in the canals. So this is one example of, when we have scouring of sediments, what is that look like? But this is from a long time ago again. All right. So this project was done on 3 farms in the EA, and I think it was done for quite a bit of time. It started before my time also, and I finished it. There were 3 farms. We always monitor, of course, the pump stations. Of course, we do lab analysis, which I talked about. So do monitor the drainage flow. We have sensors, the rainfall. We, for this particular project, took discrete water samples every hour. So let's say there's a discharge event of 2 days, that'll be 48 samples per farm. And some of the discharge events, if there's a hurricane coming, for example, or if it's a lot of water, rainfall, it can be 2, 3, 4 days, for example. So this one, we wanted to know, one is particulate phosphorus, the sediments, the soils are being exported from the farm. And so hourly discrete water samples, a lot of lab analysis, and then each water sample would be speciated again into total E, total dissolved P, particulate phosphorus, and we also have the suspended solids as well as TOP and so on. Okay. And we did sediment inventories too. So one of the things that happen with sediment transport in canals or rivers is if the velocity, if the water is moving at a very fast speed, it can move with it sediments and soils. And this erosion rate can increase substantially when you have the velocity doubling, for example. And eventually the bed can be transported. This is an extreme situation. So this is one example when you would have, this is the canal level at pump station. What is the level of water in the canal? At this particular example, it started at 2 meters. And then with pumping, the level of the canal was 0.5. And you can see there's this exponential relationship between the canal level and how much total suspended solids is being discharged. So total suspended solids is kind of a proxy for particulate phosphorus. It's how much sediments is being moved. And when you have very low water in the canals, you move a lot of soil and sediments. And the other thing we found out in this research, again, for the 3 farms, that as the velocity in the canals increased, so there's always like this critical velocity that you should not exceed, you will have quite a bit of particulate phosphorus. I love this graph. I use it all the time in my extension talks about when does particulate phosphorus leave a farm. We have a startup flush. This is after a long time when we have not had discharge. There's a lot of accumulation of sediments, of floating aquatic vegetation. When the pumps start, you'll have that startup flush no matter what, start of the season. And even if you have really very stable sediments, the detritus from floating aquatic vegetation will have a startup flush no matter what. And you might have a restart flush also. But the other thing this graph shows, by the way, the blue line is velocity in the canal. Like when the velocity increases and you have a lot of water is being moved very, very fast. And then particulate phosphorus is in the red dots. So as the velocity increases, the startup flush is very, you can see, I mean, it reached at this particular one is from 2029 milligram per liter. But then you have, when you have a lot of cumulative high velocity, it just stirs up the sediments in the canal. So water is being moved at a fast rate and it's agitated. So as a consequence of this research, which continued for a few years to got to this understanding of when is it these sediments and soils are being transported, a lot of BMPs have been implemented to reduce sediments and particular phosphorus movement. So farmers again can choose from a suite of these particulate phosphorus and sediment control. One of them is floating aquatic management to minimize how much detritus is being accreted into these canals, but reducing pumping as canals drop. So as we are reducing the volume, let's say there's a hurricane, we need to reduce the canal levels, pump for a longer period of time at lower rates, if the velocity is never high, you are draining the farm because that's what you want, but you're not scouring the sediments. The other thing that we recommended also is to remove sediment buildup from canals. So you'll see all of this equipment that are in the aquatic vegetation in the sediments, very good techniques to reduce the sediment buildup in the canal. Laser leveling is another one, so we don't have any soil erosion. A lot of farmers have laser leveling because they want to have continuous or homogeneous water table and water content in their farm. So laser leveling is very important for soil down soils. And and other things to reduce soil erosion, like having the ditch bank berm, having a sump in the canals to reduce the sediments so they don't have anything transported. So all of these BMPs are on the list and farmers use them. But we wanted to hone on floating aquatic management and how to not only remove sediment buildup, but not to have it accrete in the first place, and maybe reduce the composition of the sediments. So the second project I want to talk about is the impact of floating aquatic vegetation, and you see them everywhere. I have one specialist on mid-sized aquatic scientist. She didn't get this from Fort Lauderdale. She comes and talks a lot about these for extension. A lot of these are beautiful plants that people have them at their aquariums at home, and that they just dump them in the canals. It's a big problem for our waterways. And it's not just about sediments, it's about navigation. I mean, certain rivers in Florida, sometimes they're so choked up with this aquatic vegetation. The state of Florida spends millions and millions of dollars on controlling these aquatic vegetation. So we wanted to see the impact of floating aquatic vegetation on water quality, and can we change the type of sediments if we somehow suppress these floating aquatic vegetation. So the first thing we did, so we have all of these in the EA and a lot more. The first thing we did is we did a lysimeter experiment just using water filamentous algae to see how much phosphorus is taken out by these plants. So we wanted first to see, can we grow this vegetation and then harvest it, and that would be a way to get rid of it. One example. So this was the lysimeters that was done, few treatments. We did 2 aquatic vegetation, one floating aquatic vegetation, one lettuce. The other one was submerged filamentous algae. And then some treatments had lime rock at the bottom and some had sediments. And we did exchange of water to see how much of this phosphorus in the canal water is taken up by the plants. And these plants pick up a lot of phosphorus. So you can see from both exchanges, the canal water had a TP of 0.3, 0.5, 0.20, and it increased quite a bit in days, and this was exchanged 2 different canal waters. And the one that was very effective was the floating aquatic vegetation, because they take up a lot of phosphorus with no sediments in the water. Then we thought about it. None of us agreed this would be a good recommendation for farmers, because trying to grow as much fat, take it out by mechanical harvesting is not economically feasible or manageable. And not only that, when we talked to Lynn at some point in time, she said you might be doing more harm than good depending on what is there. Because sometimes these mechanical harvesters, I don't know if you've ever seen them, they cut up the plants and then they grow so much faster. So that was not, so we wanted to thought about like, why wouldn't we do something different? Let's go from a situation of when we have a lot of floating vegetation to a system where we suppress this to a certain degree. And what happens if we have canals that are free of vegetation? If you ever see the main canals of the water management district, at least in our area, the water management district is always managing vegetation and always spraying and making sure these canals are clean. And there's a reason behind it. So the idea, if you have a canal that is full of vegetation here, you have a lot of detritus, of course. You might have toxic conditions. You might have a lot of anaerobic release of materials eventually. So the biogeochemistry of this layer definitely is different from when you have a clean canal that you have light penetration that may allow for the precipitation of phosphorus that could be in the canal water with aluminum, iron, calcium, and magnesium. So we want to see if we test canals that have minimal floating aquatic vegetation, we're gonna call them FAF. What happens to the sediments and does it affect the water quality? I forgot to mention that per the Everglades Regulatory Rule, the research that has to be done to be in compliance with the Everglades Forever Act has to be on-farm. So on-farm research has been going on for the last 40 years. So this experiment was done on 8 farms, and we chose a farm per design. And we chose this farms very carefully. So like this one here, just like one here, they're very similar in size, in management, and how things are done. And we wanted to manage floating aquatic vegetation of the canal. So first we had a calibration period where we just monitored these farms and see the relationship and water quality between the 2 farms. And then on one farm, we imposed a regime of controlling the fat. I should say controlling because it's impossible to control, is suppressing them to 25%. We did not want to do mechanical harvesting, so what we did is spot spraying. So every 2 weeks, we would send a crew, making sure if they see small plants, just spray them, spot spray them. So we didn't want to have an infestation because that's when things get really bad. And we did this for a number of years, and we collected a lot of data. I'm going to show you a lot of these because we do a lot of data collection, and this is one example of, again, we monitor the pump stations, look at the canal levels, the rainfall, the drainage. We have data loggers for the flow velocity. Now we have refrigerated some samples always with solar panels for the water samples, and we do the specification. For this particular experiment, we did FAF, how much it is bi-weekly, like the coverage, and we also did sediment sampling. So I'm going to show you just a couple of results. So this is, as you mentioned, it was a paired from Tyson, but this is on farmers' fields, and things change on farmers' fields. We had 4 pairs of farms. This is a farm pair that really worked very well, so I'm going to try to explain it. 4702, this one here, was the treated farm. Again, we had a calibration period, and then we had a treatment period. So 4702, when we have suppressed the floating aquatic vegetation to less than 25% coverage candidates. It was very consistent. 4701, we left it to the village, whatever it was, it had a lot of vegetation. And as you can see, that relationship between the loads of, this is UAL, is unit area loads of phosphorus fluids, changed quite a bit. So there was definitely a decrease of how much the water quality in the farms that the canal that suppressed the floating aquatic vegetation. And then we looked at sediment properties. First, we looked at total phosphorus. We saw that there is a decrease in the cryptopes and was significant in concentrations of TPA in the treated farm, and the bulk density was higher. So which is what we're looking for. When we have less floating aquatic vegetation, less organic sediments, we are increasing the precipitation, technically of aluminum iron with phosphorus, the sediment bulk density should increase. In this particular farm, it worked, but not on all farms. So basically, when we looked at all the pairs, 2 farms showed this impact, the other 2 farms did not. And the conclusion was that each farm has very site-specific properties that influences the concentration of this. And this is true because we're talking about huge farms here. There's a lot of factors that are impacting what's happening. Drainage is often a dominant factor. So even if we have like impacts on concentration, the drainage factor impacts the loads much more than the concentration. So what our recommendation to the growers is farm specific of how effective FAB would be on water quality. But in our extension, we always say control FAB, suppress the FAB as much as we can, and everybody does it. Because it's not only about water quality, it's about the hydrology. Because you can move water much easier when you have less vegetation and when you have less sediments. And then you can clean your canals much less frequently. But what if my postdocs look at this data in a different way? So we forgot about the farm fair design and said, let's see what is, we have a relationship between how much coverage we have of the floating aquatic vegetation, where the total P concentration in our drainage water, and also if there's a correlation between sediment P and also TP. And this relationship stood. So as you can see, it's very diffuse, there's a lot of noise in it, but the higher the FAB coverage in general, water concentration of phosphorus is higher. And it's really a very complicated relationship because remember when I told you that these vegetation take on phosphorus. So they can clean up the water, but then they die and they put it back. Yeah. Complicated. But sediment P, I know it's like everything else in life is complicated. So sediment P also has that relationship with concentration. But then when we try to find this relationship with the load, that relationship breaks down. So, the unit area load, this is not important because, of course, it will have a positive relationship with the flow and the concentration with the load because that's normal because the load is a component of concentration of flow. But the mean velocity, remember, talked a lot about velocity, definitely very strong relationship with unit area loads. So the higher the velocity in the canal, you definitely have higher loads. But when we looked at the relationship between coverage of FAB and sediment depth with the loads, there was no relationship. So, which tells us again, the hydrology is a big factor compared to just the concentration. And remember, for the EAA, it is the loads and not just the concentration. For UAL, had no direct relationship with FAB coverage of sediment, which was surprising, but this is why we switch. So for this particular experiment, the conclusion was hydrology, flow, volume, and velocity was again most influential factors. We just trying to really rationalize why this happened. You know, a lot of these farms had different control practices that made this comparison very difficult. But the most important thing is we still recommend FAB controls for farmers for suppression. Okay. So the last thing I want to talk about is putting everything together. So we talked about partial phosphorus, we talked about flows and sediments like that. For this current research project, we decided, okay, we need a more comprehensive way of looking at things. It's not going to be one thing or another. Let's look at the soil chemistry. Let's look at cropping practices. Let's look at the hydrology. Let's look at the sorption capacity and try to evaluate the impact of all of these on the water quality. So this is the current project that we have. And by the way, this is the organic soil, like how dark it is. So this is typical. We have an O horizon and a C horizon. So this research now is going on. It is on 6 farms. This is a farm bird design also. We chose farms that have the same prepared farms, that they have the same operator, the the same best management practice plan. By the way, this is a good example of what our management BMP plan for a farm. So as you can see, for example, this particular farm, Tina 1, has nutrient control BMPs, particulate control BMPs, water management, and total. And you can see this is a sugarcane farm. This one in the middle is a vegetable farm, sugarcane rotation. So the first is for pair 1 and pair 3 are sugarcane farms. The one in the middle is a vegetable farm, sugarcane rotation. And one of the things that I didn't talk a lot about is that our soils are different, of course. Soil depth was one of the factors for looking at, because some of our soils are getting shallower because of oxidation. And so we're measuring soil depth also. So we chose farms that are paired, that have the same operator, same BMP, the same crops, the same soil type, same everything, but they have different water quality content. So if the same farms are using the same BMPs, they have the same soil, they have the same cropping practices, why do we have differences in water quality? And we have these farms in 3 different pieces. Again, same methods, we monitor the farms, do a lot of analysis, but in addition to that, we are measuring soils now on an annual basis. So we collect about 15% of the farm area sampling. We do soil depth, pH, carbon, total P content, available P content to methods, and mineral content, calcium, magnesium, iron. And we did substructure experiments also. So I'm going to show you a few results and to be continued. So maybe you can invite me in a few years. So I just wanted to show you some of the differences in soil properties of the farm pairs that we have. PW is phosphorus extracted with water, and we do that for our organic soils, especially for this vegetable production, because it is continuous burden of phosphorus, like 30 dissolved phosphorus. And we also extract them with malic 3, which gives you like bone sugar. This is used for sugarcane. So pair 1, 2, and 3. First of all, you can see there are quite a bit of differences in how much phosphorus is in these soils, quite a bit. And then you can see in some of them that actually, even in the same management, they have differences in the amount of phosphorus. So that's very striking that you think they're homogeneous soils are never homogeneous. But because they're organic soils, they're managed the same, you think they'll have similar properties, but they're really different. And that was really starting to see. And then we looked at phosphorus sorption capacity. So we looked at maximum capacity, S-max, which is the maximum sorption capacity. Again, to the 3 pairs. And there are differences between the 3 pairs, but between the pairs themselves. So even the sorption capacity, again, which is linked to aluminum, iron, and organic matter. We did some correlation, and you can see the S-max is definitely correlated with the amount of aluminum, iron, and negatively correlated with organic matter. So the higher the organic matter in the soils, phosphorus would be more in the soil solution, less retained by the cells. Now, this relationship, if you're soil chemist, between S-max and total P possibly at the beginning, but I think it's because when you have more iron and aluminum, you probably have more phosphorus, and that's why you see that relationship with S-max. And the last thing we're looking at, of course, is water quality and comparing the pairs, right? So this is flow weighted TP, this is the drainage, and this is incident level. And we're comparing the pairs. I don't remember how many years we have this. I think we had it for 3 years when I put this slide together. But again, the water quality is impacted even in the farm pairs. So we still have seen differences in water quality in terms of flow weighted TP and this one. So pair 1, pair 3, definitely there's differences in water quality. And of course, with the interior lower, there are differences, especially compared to and pair 4. So as I mentioned, this is an ongoing research. What we are trying to do is by collecting all of this data, so we've got soils, sediments, water, and now we're going to collect also vegetation data, is to have a holistic approach to modeling, okay, to evaluate really what are the factors impacting water quality in general from a comprehensive I'm not a data specialist, and I'm not an AI specialist. I have a colleague in Gainesville. She's in this project, and she is working on deep learning, predictive, and explainable AI models. We're characterizing, in addition to the stuff that I talked about, some chemical and physical factors, looking at other geo-environmental factors, and we're looking then to evaluate these phosphorus rates. So some of the geo-environmental factors we're looking at is doing remote sensing spectral data of plant and vegetation, because it's very important for us to look at the cropping history for the last 30, 40 years. So we're gonna try to do this from data that is available. And also look at high resolution soil characterization data sets, because we do our own analysis, but we wanted to do it in detail. So there's a lot of 100-meter resolution from SOLAS, from USDA, and of course, look at long-term climate data. And the other thing that we're doing is, this is like a separate thing, is doing spectral scanning for soils and vegetation, and trying to have a model to predict some elements of the soil also. So that's another objective. And eventually, at the end of the day, we're gonna build this database to link the geo-environmental factors with the points on specific soil sample locations, train, develop these predictive, explainable AI models. The objective is to predict kilos in these selected farms. It's not going to be all the AAA because it is very farm specific. These selected farms using the geo-environmental data, using the soil chemical measurement, soil spectral data, and then access the performance and try to predict what really impacts the water quality when nothing else explains it. So a few other things I want to talk about is, I said part of this program is training, very important. Every farmer in VA that works on the farm manages to have to do training once a year. So we offer in-person workshops twice a year. But since COVID, I have a lot of these online. So we have completely online VIP training class that they can attend if they want to completely online. And we usually have excellent attendance, and it's quite a bit of interact. So we learn from them as much as they learn from us too. And as you know, I'm sure you've seen this before, this program is quite unique. I talk about it all the time when I go to meetings, both national and international. It is really a combination of factors that came together: research, 100% participation by growers, and of course, the mandatory part from the water management district. So it's a combined effort of the growers. They do quite a bit in the space, and they're really stewards of the land and water quality, the water management district, and of course us. But this program, if you remember the phosphorus load reduction, it needed to be at 25% load reduction. This is mandated by law. Every single year except one, it has been 4. The average for the last 7 years has been 27%. But even at the 18% here, we were never out of compliance, because according to the rule, it has to be 50 years in sequence. But this is how much metric tons of phosphorus have been removed from being discharged into the STAs, now, of course, the structured areas and the Everglades system because of the So it has been quite a bit of successful program. And of course, it's a continuous program. All right. A few more slides about Soil Science Society of America. Who here is a member of Soil Science? Oh my God, 1, 2, okay, who else? Oh, good, yes, yay. Okay. Well, I'm past president of the society. If you work in soils, you need to be a member of the Soil Science Society of America. We have a lot to offer, right? We have a wetland division, we have a biology and biochemistry division, we have a soil chemistry division, mineralogy division, so you're more than welcome. We have over 6,000 members and 500 plus certified professional soil scientists. Our mission is very simple: to advance knowledge and appreciation of soils as a foundation of life. In 2028, the meetings will be in Fort Lauderdale. So if you're a student here, yeah, membership is for students, it only takes like $50 a year. So it's not huge. And you grade a lot. So part of what you gain is networking, career service, a lot of awards for graduate students, a lot of professional development. Actually, we just had a call for the World Congress of Soil Science. It's in Nanjing, China this year. So we had a call for students who wanted to go. We had 10 awards, $2,000 each, and we awarded the 10 awards this year. So we have a lot of students going to China, hopefully, to be part of the World Congress provided by the society. We have a foundation, the Society of Sport and Environmental Science Foundation. We have a lot of endowments from people who benefit a lot from the society, and they keep back by giving. So if you're interested, just shoot me an email and I'll. Thank you so much.